In this example, we're told that the elevator in a building has a sign that says the maximum capacity is 1,480 pounds or 10 passengers. So since 1,480 divided by 10 gives us an average of 148, this converts to a mean passenger weight of 148 pounds when the elevator is full. So if you can imagine an elevator that is at maximum capacity, if 10 adult males get into the elevator and they each weigh 148 pounds, that puts the elevator at maximum capacity. So if one of those male passengers happens to be more than 148 pounds, I hope that you can see that that would put the elevator over its maximum capacity, which could be a safety issue. So what we want to ask ourselves is, what is the likelihood or the probability, right, that the elevator, right, might be over its maximum capacity, which is at a level where it's not safe. So is that probability high? Is it low? What is the actual probability? And we can answer that question by looking at some data about male weights. So here we're going to assume the worst case scenario in which the elevator is in fact filled with 10 adults. So using some data about male weights, we know that adult males have weights that are normally distributed with a mean of 189 pounds and a standard deviation of 39 pounds. I tell my students that anytime you read a problem where you're told that your data is normally distributed, I want you to immediately draw yourself a bell-shaped curve. So before I even begin reading the question in question A, I'm going to go ahead and draw myself a bell-shaped curve that represents adult male weights with a mean weight of 189 pounds. So I go ahead and write that down off to the side here using the correct notation to remind myself of the information that I have. So 189 pounds is the mean weight for adult males with a standard deviation of 39 pounds. And then I'm going to go ahead and just label the center of my distribution with that mean value of 189 pounds. And again, I'll just make a note down here that this is male weight, adult male weights. Okay, so I want you to imagine that this bell-shaped curve is made up of a whole bunch of x's, where each x represents an adult male and his weight. And so majority of adult males are going to have weights around 189 pounds. And then, of course, as we move to the right of the bell-shaped curve, we're going to have fewer and fewer males that weigh more than 189 pounds. And then to the left of the bell-shaped curve, of course, we're going to have males that weigh less than 189 pounds, but that also gets smaller and smaller because there are going to be fewer men who weigh less than that mean weight. Okay, so I'm not going to draw all the X's, but I hope that you can imagine that this bell-shaped curve is made up of every single adult male and their weights. Okay. Now let's take a look at question A. We're asked to find the probability that one randomly selected adult male has a weight greater than 148 pounds. So what this question is asking us is asking us to do this. I'm going to use the notation P for probability. What is the probability that one randomly selected adult male, so one X value chosen at random, is going to be greater than 148 pounds? So to answer this question, we need to calculate that probability or that area under the curve that represents X values that are greater than 148 pounds. So I'm going to mark on my distribution here where I think 148 pounds is. So it's okay if it's not perfect. I just know that 148 pounds is less than 189 pounds. So I'm going to mark it there. And then I'm going to very quickly shade in, right, the part of the distribution that represents all the X values, which means all the male weights that are greater than 148 pounds. So I hope you can see that all the X's that are under the red shaded region under the curve represents adult males who weigh more than 148 pounds. So all the X values that are in the red shaded region. So this area under the curve that's shaded in red, that area corresponds to the probability, right, that a randomly selected adult is going to weigh more than 148 pounds. So how do we find that probability? Well, if you're using your calculator, so I'm going to use the calculator in this video here. We're going to use the function normal CDF. So go to your calculator and go to normal CDF. And the first thing that we're going to put in is the lower bound. So in this particular problem, that lower bound is 148 pounds. And then we want to know all the x values that are greater than 148 pounds. So I need a very large number. So you can either type in 1E99 or you can type in a very large positive value. So your textbook says you can use a number like 999,999. But I'm going to use 1E99 on my calculator. And then the next piece of information your calculator is going to ask you to type in is your population mean. So here that's going to be 189. And your population standard deviation, which here is 39 pounds. And then if you press enter, right, the calculator is going to give you a value of 0.853, which is approximately 85.3%. So we can conclude that approximately 85.3% of adult males weigh more than 148 pounds. In conclusion, the probability that one randomly selected adult male having a weight greater than 148 pounds is approximately 0.53 or 85.3%.